Reinforced backfill retaining wall with rigid facing structure is a new type of earth retaining wall, reinforced backfill retaining wall, which has been developed as an alternative to conventional earth retaining structures and which is based on the principles of soil reinforcing. The embankment backfill soil is reinforced by polymer planar materials, geotextiles. The reinforced embankment is first constructed in several stages, and then a nearly vertical RC wall is constructed and carefully integrated with the reinforced embankment. Reinforced backfill retaining wall is a type of structures that can be constructed following the 3R construction method. In addition to this, reinforced soil bridge abutment, reinforced cut soil retaining walls with rigid facing, and waterfront disaster mitigation reinforced soil structures can be constructed. All these structures are being widely used for ordinary embankments, retaining walls, rebatment structures such as course and reservoirs, as well as for abutments and bridges. What would you do to make soil or ground stronger and harder? When the dry beach sand is poured on a level ground, the heap of sand generally rises at an angle of 30 to 40 degrees. But what if, for example, you put pine needles in this dry sand? The result is that the heap of sand can rise at a steeper angle than if you didn't put anything in it. This is the origin of the idea of soil or ground reinforcing. In the case of reinforced concrete, a concrete that cannot be expected to have tensile strength or bending strength can resist tensile stress by reinforcing with steel bars or wires. Similarly, in order to prevent tensile or bending fracture of soil or ground, it is possible to construct a stable soil structure by laying or placing various functional reinforcing materials in the backfill soil or supporting ground. This is the principle of reinforced embankment. I will briefly explain the mechanism of the reinforced embankment. In the reinforced embankment body, a tug of war is played between the mass of soil that is about 2 clods and the mass of soil that is about 2 holes through a friction of reinforced materials, geogrids. If this tug of war is out of balance, the reinforced embankment will collapse out. 3R construction method makes it possible to build nearly vertical retaining walls and abutments by integrating planar or rod-shaped reinforcements with a rigid wall so that this tug of war remains balanced. Reinforced backfill retaining wall with rigid facing are structures for which it is possible to construct a nearly vertical retaining wall using planar reinforcement and rigid wall. Place the first layer of geosynthetic reinforcement and rubber-filled bags or welded wire mesh boxes. Then place and compact the first soil layer. Construct the second layer in the same way as the first layer. Complete the full-height geosynthetic reinforced soil wall by repeating the same procedure. Once deformation of embankment and supporting ground has stabilized within the allowable value, cast concrete directly on the wall face, ensuring firm connection between the facing and geosynthetic reinforcement layers. The rigid wall and geotextiles are completely integrated by casting concrete without back formwork. In addition, bleeding water from fresh concrete is absorbed between the gravel particles in gabions or welded wire mesh boxes, and the concrete becomes solid. After completing the geosynthetic reinforced embankment, the wall is finally constructed. The advantages of such a stage construction are as follows. By casting concrete after having waited for the deformation of the embankment body and supporting ground to stabilize, damage from relative settlements does not occur at the connecting points between the rigid wall and reinforcement geogrids. Therefore, it becomes possible to construct such reinforced soil retaining walls even on soft ground that shows extremely high compressibility. In addition, the fill cell that will be located directly behind that wall can be compacted with heavy machinery, etc., and sufficient tensile force can be mobilized in the reinforcement even during embankment construction. Since concrete formwork on the wall front side is supported by members inside the embankment, it is possible to cast a rigid integrated wall facing in a narrow and limited space. Since the wall concrete facing is cast, once deformation of the supporting ground has stabilized, wall shape and specifications can be precisely respected. Since the reinforcing material is a grid-like planar reinforcing material, interlocking and friction with the soil can be easily activated, and layout length of the reinforcing material can be short. Since planar reinforcements are relatively densely arranged, the range of application of the reinforcements that can be used is widened. Seismic performance is greatly improved because the reinforced soil retaining wall is constructed by integrating the wall rigid facing and the planar reinforcing materials. It is possible to build a vertical or nearly vertical wall surface, and use land can be significantly reduced compared to conventional embankments. Since the structure does not require pile foundation, it can be constructed without using large heavy machinery and on a narrower side or in a narrower place than conventional retaining wall. Reinforced backfill retaining wall with rigid facing is a new type of reinforced soil retaining wall that has been developed by combining many ingenious features such as those that have been described.